So today is good morning Neha. Today is the first day in December. Hopefully this cursed year ends soon without any more damage. So just let me take your attendance. So Suvayu, Neha, Nirupan and Neha. Oh, Priya has also joined. Okay. So let's begin the week with the prayer. Just make ourselves, just make each of you just sit in a relaxed posture. Breathe in the fresh air of the morning. Exhale all the worries,
Good morning,
all
sir.
the negativity. Good morning, Ajit. Let's thank God for everything. Let's pray to God that this coming week we can strive to be even better than before. If possible, let us bring smile in some faces around us who are drowning in sorrow by sharing some time with them. Maybe not by money, but by being something called empathetic. Let us pray God. Let us pray for the good health of our parents, our siblings, our friends, and let us pray together. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from all evil. Amen. Okay, so good morning once again, everyone. Uh, I can sense there is a lot of confusion, queries in all of you regarding this exam. So I suggest that first let me finish the teaching business for the day. Okay, don't worry. I'll give some time for you to ask the questions regarding the exam. Hmm. Then we can discuss that. Don't worry. We'll tell you everything about that. It's your first time. You would be giving an online exam like this. I can feel that. Okay. So talking about the teaching business, we did up to the equation of a conic, and we got the idea. No, we had the idea before actually. We just recapitulated it, and now there's something called effective potential that is also important. This would help you for the rest of your life if you want to live uh, a physicist's life. Okay, but I think that part would be a bit difficult for you to digest. Mm, so I want to discuss something that you already learned in your school days. That is the Kepler's law of planetary motion. Before go into Kepler's law, Johannes Kepler, uh, in almost all the standard books, you'll find a name that will come before him, Tycho Brahe. I don't remember his nationality correctly. I think he was Danish. He was from Denmark. He was a Danish aristocrat um, who studied the uh, planetary motion with very crude optical instruments. And his results were that the conclusions that he made were very, very accurate. Okay. And it was Johannes Kepler after him who studied these observations with great details, and he formulated three laws known as the Kepler's law of planetary motion. Uh, you may find it this bit coincidental, or just, or maybe there's a reason that the most celebrated law in physics, physical sciences, Newton's law of motion, they are three in number. The Kepler's laws of motion, planetary motion, is also very, very fundamental if you want to study planetary motion. That is also three in number. Now, when you will study the chapter called electromagnetic induction, where Michael Faraday uh, did some great job that brought revolution in science. So, the laws of electromagnetic induction is also three in number.
Sir,
Yeah,
the shade skin is not visible, sir,
which
properly.
screen?
Sir, you're sharing your screen, nah? That's not visible properly.
Is it with
Yeah,
everyone?
yes, sir.
Uh, okay, I'll then pause a little bit. I am monitoring everything from another screen. Here it is okay. Maybe there's some network problem out there. Is my screen blurred with everyone?
Not with me, sir.
Ajit, is it same till now?
Now it's okay, sir.
Yeah. Yeah, please just prompt me if it happens. So you see the number three, maybe there's some connection. Okay. You can spend some time after your class doing this, just checking out why this number three is so important, or maybe it's just a coincidence. Anyways, so let's move into physics. So what are the three laws? The laws don't have any name, okay? They were simply when they were compiled, they were written like first law, second law, third law. Hmm. I read somewhere that it is not. There is no hard and fast rule that this has to be the first law, but it has over the years it has become a norm to write the first law as this one and so on, and the second law as that one. So the first law is what? It says that all planets move in elliptic orbits, that is in an ellipse, around the sun that occupies, that is the sun occupies one of the foci, that is foci is the plural for focus. There are two focus or two foci rather in an ellipse, foci of the ellipse. Okay, you need not to copy everything. If you have any A.B. Gupta's book or any mechanics book, you'll find these statements there. I'm just writing the gist, okay? I mean what they mean. So all planets, that is, let us draw the picture that would make everything clear. So I can draw an ellipse. It's not the perfect way. You can go to the internet and see how you can draw ellipse without any instrument. You just need a pin, a board pin, a pencil or a pen, and a string kind of thing. Don't use a rubber band. Or yeah, you can do with the rubber band. Sorry, you have to use a rubber band, I think. You can make that. I don't remember the exact process. You have to put two pins here on a straight line. Anyway, so it is saying that the planet always moves in an elliptical path. This is contrary to our uh, childhood learning that it moves in concentric circles. The sun being at the center of the circle or the orbit, circular orbit. And these things all came from observation. Okay, they didn't come out of thin air. Um, and what where the sun is located, it the sun may be located at any one of the two foci. So this is the place of one focus. I can write it as S dash, or it can be on the other focus. It depends. There are two suns won't be there only. Either it can be here or it can be here. But previously, when we considered circular orbits, this uh, option was not there. There is only one center. That is, if you think, if you want to relate this focus thing with a circle, you can think, say it's like the center of the circle. So that is what the first law tells us. That reality check, it's not a circle, it's a ellipse. Circle may be a special case. What does the second law say? The second law, little bit we studied in other form while studying the feature of motion in the central force. The radius vector, say r vector of the planet from the sun, that is simply, it is the vector that uh, gives the distance of the planet from the sun, sweeps out equal areas in equal times. I think this thing we studied in our second or first lecture in this topic, that the areal velocity is constant. What is areal velocity? I said it is the rate at which the area is being swept. Okay. So what is this thing? What does it say? It says kind of this, that say the planet is here, say at any instant it is at P. From here it has moved to say P dash, any other point. And the sun is suppose here. I said any one focus. So suppose the sun is at this focus. So what is the radius vector at this instant of time? It should be this thing. After a given time interval, say the radius vector becomes this. So what is the area that it swept? That is this entire area. Okay. So this is what we mean by sweeping out area. Fine. Now if at the same, in that same interval of time, say 1 minute or 1 hour, that doesn't matter. I mean, interval has to be same. Suppose the planet reaches at P double dash. Say it was at the beginning. After 1 minute, it came here. In the next, after the next 1 minute, it came here. So what would be the area now? If I connect with this radius vector now, the area would be like this. So according to Kepler's law, these two areas should be same. Is it clear, everyone?
Yes, sir.
This thing is equally valid if the sun is on the other focus. Okay, and the third law, that is about the time period, though it doesn't have any name like that. So the square of the time period of revolution. Okay, revolution, that is for our Earth, 1 year, 1 solar year, or 365 days. So the square of the time period of revolution of a planet is directly proportional to what? To the cube of the semi-major axis of the elliptic orbit. Now, is anyone having any doubt regarding semi-major axis? Is it the first time that you are hearing this name? Don't feel shy. If yes, tell me, because I know your +2 syllabus is a bit uh, disoriented this time. In odd times, it was not like that. Okay, fine. That is this. If this entire the longer line here also, I can draw a line like this from its midpoint perpendicular. So this longer length would be the major axis, and half of that is the semi-major axis. Okay, so Kepler found that the time period of revolution, say capital T, its square is proportional to the cube of the semi-major axis. And I told you that it is a norm to call the semi-major axis as 2a, not a. And the semi-minor axis as 2b. And you know the equation of the ellipse looks like x square by a square plus y square by b square equals 1. Hmm. So what is half of that? Half of that is a. Half of 2a is how much a? So this law is very important for you all because numericals may come. Hmm. So I think everyone, most of you knew these laws. So just a brief recapitulation. So now these laws look very simple, but people were not willing to accept them. Now this law had to prove itself by proving something which has been there for a longer period of time and which is more globally accepted. That is, the challenge was to prove the law of gravitation from Kepler's law. Law of gravitation put forward by Isaac Newton. If that law uh, comes from these laws, then yeah, this law is acceptable. Did you get it what I'm telling? Is it clear? And this thing is there in the book also, but it's a bit tricky. I am I had a note on this, so after the class I'll just share the pictures, the notes. Okay, because I think due to the network problems, if someone misses out any important part, then it would be difficult to reassemble everything. Anyways, so how can I derive or deduce the law of gravitation from Kepler's laws? There is proof of Kepler law as well, but I think I can do this. Let me check once. Do I record anything extra? No, I don't record anything extra. So basically, we'll begin from with the first law, which tells it is the orbit is elliptical. As simple as that. So we know the equation of a conic Is Neha, can you tell me what is the equation of a conic? Any conic? Yes, Neha. I hope I'm audible. What is the equation of a conic, Neha?
L by R is equals to 1 plus E cos theta.
Yeah, very good. It's not E, it's actually epsilon. It's a Greek letter. Okay, yeah, good. Yeah, E also, I think in your school days you used to write it by small e. Yeah. So L by R equals to 1 plus E or epsilon cos theta. The terms are self-explanatory to you, I hope. Hmm. And this thing may look bit annoyed, but they helped us over the past few weeks. And what is H? What was H? R square theta dot, right? Was it R square theta dot or half R square theta dot? H?
So r square theta dot.
R square theta dot, right? I think there's some mistake in my note. R square theta dot. Just check it once again before I send you the entire thing. Yeah. So what is the radial acceleration? The radial acceleration ER equals R double dot minus R theta dot square. Now we'll try to find this R double dot and theta dot rest of the thing from this equation. Now that's the equation of the conic. It's 7 past 9. I think I should go till 9:20 past 9. Then the last 10-15 minutes we'll discuss about the exam. Okay. So if I do the, oh, let me write. If I differentiate both sides with respect to time, that is t, then what we'll get? L is constant, the same lattice rectum. So it's only the time derivative of 1 by r. And I won't repeat this thing in details. Last time I'm doing it, that if you have ddt of say r to the power n can be anything. Like here n is minus 1. So what we will do? We'll do ddt r of r to the power n, then we will do dr dt. That is, it would be derivative of r to the power n with respect to r and r dot. We did it before also. So here what we will get? L, and what is the derivative of r to the power n? N into r to the power n minus 1 r dot. So what's n? N is minus 1. So minus 1 r to the power n minus 1. That is r to the power minus 2. That is L by r square r dot. Please tell me if you understood this or not. Is it clear, Ajit?
Yes, sir.
Okay, fine. 1 is a constant. Eccentricity, epsilon or E, that's also constant. So I have to just deal with cos theta. Same thing, cos theta derivative with respect to time. That is ddt of cos theta, theta dot. So minus sine theta and a theta dot. Just notice I kept a gap between this theta and theta dot so that it doesn't look as the angle of sine. It's a multiplicative thing. Anyways, so what I will do next? So you can see minus signs on both sides. They won't be present in the next step. L r dot r square I will send on the right hand side. Uh, so r square theta dot sine theta. This looks better. What is r square theta dot? H. I missed an epsilon, right? Yeah. It's H epsilon sine theta. Clear, everyone? So now let us find what is r dot. Just transposing the terms. R dot would be H epsilon upon L sine theta. Has everyone arrived till here? I have to turn the page. Done, everyone? Nirupan, is it okay, everything? Or Siddharth woke up? Siddharth finally. Nirupan, is it okay?
Yes, sir.
Okay, fine. So let me flip because I need to find r double dot. This term is actually what I am looking for. Let's do the derivative again. So I'm not writing the entire dialogue. You can write it again. Let me write differentiating with respect to time. So I would get what? What was on the left hand side? R dot. So I'll get r double dot, obviously. On the right hand side, epsilon h by L, constant things. Then I had a sine theta that would give me cos theta and a theta dot. Now I have to somehow get rid of this theta thing. Okay, how? In two steps. First, this thing is constant. So I have a theta dot and a cos theta. So uh, what is h? H is r square theta dot. So theta dot is nothing but h by r square. No big deal. H upon r square. Now the trouble may be with cos theta. Apparently, cos theta came from this equation of the conic, right? Just simply you have to find cos theta is equals to how much. So epsilon cos theta would be L by r minus 1. That means cos theta is L by r epsilon minus 1 upon epsilon. Okay, not that difficult. So that value of cos theta I'll put here. Now just multiply and separate the two terms because in the bracket it is a minus b kind of thing. Just multiply this with both the terms. So I will have epsilon h square upon L r square into, from here I will get L by r epsilon minus epsilon h square by L r square and an epsilon in the denominator. Let's see if anything can get cancelled. Epsilon epsilon gone, L gone. Epsilon, epsilon. So the first term will give me h squared upon r cube. Second term would be like h squared by L r square. So finally, what is the radial acceleration? R double dot minus r theta dot squared. Put the values. What is r double dot? This thing only. H square r cube minus h square by L r square minus r theta dot square. R is r. Theta dot means what? H by r square. So theta dot square would be h squared by r to the power 4. Hmm. This thing will get cancelled. That is h squared by r cube minus h square by L r square minus h square by r cube. H square by r cube gets cancelled. So my radial acceleration looks like only h square by L r square. We are nearly at the end. The final duel is just few steps away. Everyone okay till here? Please confirm.
Yes, sir.
Lachung, is it okay? Is it okay, Lachung? Fine. Okay. So now just come to the Newton's second law. The force on the uh, planet due to the sun is simply what is, let me write it like this: force on planet due to the sun. You can write anything, you can just write it F1 F2. So force on planet due to the sun, that is goes to what? Mass into acceleration. So mass of the planet into this radial acceleration. Yeah, let us assume that small m is the mass of the planet and capital M is the mass of the sun. Obviously sun is fatter than all the planets, so m is greater than n, or much greater than n. Just put the value of this radial acceleration, so minus h square m by L r square. Similarly, what is the force on the sun due to the planet? That is force on sun due to the planet. So mass of the sun into the acceleration. R square. Okay. So now 2 minutes left, I can see. Now by Newton's third law, the magnitude of these two forces has to be equal. isn't it? The individual magnitude of the force, that is obviously that would be different. That's a different thing. But the action and reaction forces are equal. That is minus h square m by lr square is equal to minus h square by m lr square. So force being equal doesn't guarantee the effect should be equal, isn't it? The one that has a larger mass, that will move very less compared to the lighter one. If being equal means what? M into A is constant. That is, M is inversely proportional to A, or A is inversely proportional to M. So the sun being very, very heavy compared to the planet, it won't move that much as the planet will do. Is it clear? Is it clear, everyone?
Yes, sir.
Fine. We should have taken a constant in the default step. Let me see if it's necessary here or not. Hmm. K is the constant. Actually, this entire thing is a constant itself, apart from M. Okay, let us pause here. I think it's already 9:20. Let's discuss about the exam. Okay, yeah, please just tell me what queries you have. Priya asked me something last evening. So, is anyone else having any doubt? Any query, anything? Please ask. Or is everything clear? How you will write the exam?
No, sir, it's not clear.
Achha, yeah. What doubts you have? Where to write the exam, right? Where to
Yes,
write the
sir.
exam. So the exam has to be, no, you don't need to come to college at all. That's why you are taking this thing in the online mode. So the exam will be on Moodle. Moodle, you know, where I put all your the courses there. Moodle has a provision, very good provision of taking online exams. So this exam would be both MCQ and short answer type. Just let me read out just hold on, the detailed question pattern. The question pattern would be, there are a difference, same for all the subject except EVS. Hold on, hold on. So do you know what is the full marks of your each paper that you have? Have you gone through that in the university website? CBCS system, what is full marks for each paper? I don't think you did. Yeah. So the pattern would be, since we have practical papers, that thing has not begun. Don't worry, don't panic. Okay. So our pattern would be the exam will be of 60 marks total, out of which 20 marks will be MCQ. That is 10 MCQs of 2 mark each. So 10 into 2, 20. 20 marks is for short question, short answer type questions. That is 4 questions of 5 marks each. So 20 plus 20, 40. So this 40 marks exam you have to give online. The time limit is 2 hours. And I'll show you. I will just make a dummy test for you people, because we showed that in our that orientation day 2-3 months back, and I'm sure all of you have forgotten it. That's pretty obvious. Hmm. And there is a clock automatically running in that exam. I don't know how many of you have given any online exam till now. I don't think most of you have appeared for that. There is a clock at the top of that exam page. That will automatically start running when the exam begins. So 20 marks MCQ, 20 marks short answer type, that is 40. 20 marks will be a 5 hour. Okay, so 20, 20, 20, 60. 5 hour will be not on in that 2 hours, obviously, after that. And 10 marks is for your internal assignments, and 5 marks is for your attendance. Okay, so it's total, it is 75 marks. That is how the actual pattern is. So let's not tamper with Kepler's law. Let me write it down here. So MCQ would be there, 10 MCQ of 2 marks, that is 20. Okay, and short answer type, short answer type would be 4 questions of 5 marks, that is 20. This 40 marks exam will be for 2 hours. Then there would be 5 hours. It may be on the same day. We'll try to do it on the same day so that you all get rid of all this examination stuff. So 60 marks. And something called CIA. CIA stands for Continuous Internal Assessment. Not only assignments that we ask you to do as homework, but your attention in the class, your performance, everything comes under this category. That is total 10 marks. And your attendance is worth 5 marks. So if you do the total, it would be 75. So this 40 marks thing, this will this is something we call a quiz type exam on Moodle. So you have to give 2 papers of 40 marks on 2 consecutive days, CC1 and CC2. Is it okay?
Yes, sir.
And the short answer type, this MCQ is okay. You can just click on the correct option. The short answer type, whether you have to type it there is an option, there's an editor, you can type it on the screen, or whether you have to click photos and upload, that will tell you. Okay, just confirm it once. So on 14th and 15th, you have to appear for CC1 and CC2, and the remaining days you have, I think, your GE and AECC. So I think this is the best time to begin revising. If you have any doubt, we can just recapitulate that. So that is about the exam. And I was just looking for any extra spare test if I had, but unfortunately the time of all the tests have elapsed. Um, just wait a minute. Editing. Let me see if I have a test at hand. So today is 1st of December 2020. So let me try to turn on a test that I took last year, and not last year, last semester rather. And yeah, there is a separate, what should I say, course created for you for the exam. Will tell you everything. That won't be on your CC1 and CC2 course page. Okay, I would suggest that don't panic too much. This would be very easy, not that difficult. Uh, just focus on your revision. So is my screen visible to everyone?
Yes, sir.
Okay. So this is some course your seniors had last sem, analog electronics. So this is a quiz. Let me show you how it looks like. Mm. You won't get the preview option. Okay, here you would get something called start the quiz. You can see here the time will be given that the quiz will open on this day at this time, and it would run up to the same day that time. And once the quiz runs out of time, you won't be able to join. Okay, so let me show you how it looks like. Say it's a numerical answer type question, that there's something called ideality factor of a silicon diode. And you can see here there will be written that marked out of that is what is the full marks. So suppose I am putting a value, say I don't know, say 10. You can flag the question as well. Flag means you're a bit doubtful regarding this question, and here you will see the total number of questions that you have to attempt. So you want to return and revisit this question once again. So when you press this flag thing, you see there is a red kind of thing here, and this is the clock. In the national exams, it is at the top. We keep it here because at the top people get confused with other options. So
Sir, I can't see, sir.
yes,
Sir, you're showing the procedure, but I can't see that, sir.
is it with everyone? You do one thing. You just unpin. You have pinned me in this Google Meet maybe. There is a board pin kind of option, thumbtack kind of option. Just remove that.
Yes, sir. Done.
If you pin someone, only that person will be visible throughout the screen. Okay, so what I was doing, so this was my first question. You won't be getting this kind of question, just numerical type question. So suppose I put the answer 10. Then next page. See, it is coming to the next page. Then yeah, these kind of questions you will get MCQ. So which material is suitable for construction of LED? Something, say I put this thing. If you press clear my choice, everything would be cleared. Only everything, I mean the option, the answer you put for this question only. So just press here, go to next page. Here also we have another numerical answer type. Say I put it like this. So this is how you will just give the options and proceed. Say let's do it. Not that difficult. you may get some numerical problems as well. I mean, the numerical you will do in your copy rough and just click the correct answer. That is how physics entrance exams occur all over the country. So at the last, you will get the finish attempt. So once you're finished, you will get this thing, your summary of your attempt. That, yeah. If you don't answer anything, if you left anything, maybe here you will get unanswered kind of thing. Now you can either return to the attempt. Suppose I want to return. I am in doubt with this one. I will change it to say 2. Then next page. Now you want to finish your attempt, right? And say, suppose this one you have a doubt, this question. You will leave it, you will not answer it. So clear my choice. And if you don't press next page, it won't be saved. So see, the color is here, it's blank. There is no color. That is, you didn't attempt it. So how to go to the end? How to finish it? Just click here, the last question. Then you will get an here also you have either you can go like that, or always you have an option called finish attempt. Once you click it, see this thing you didn't answer, it is written as not yet answered. Suppose you are done with everything, so submit all and finish. Then another pop-up will come that are you sure you want to submit, because once you submit you cannot change your answers. Yeah, this thing teacher will be able to see, you won't be able to see this. That is which options were correct. So is it clear how you have to mark your answers? Don't worry, Ajit, I'll tell you. Don't think that we'll finish something on the day before the exam and put it as a syllabus. Okay, we won't be doing that. We'll see how much how far the syllabus would be easier for you to digest. We'll discuss that. But till now, you can think for my part up to what I taught today. That can be the syllabus maximum. Fine. We'll just discuss how much syllabus we'll put into this internal. And before the main exam, we'll just do a test run as well. We'll just try to have a test exam with you all so that you can just do it or not, whether you have any issues submitting the answers.
So when we have our Viva?
Viva, see, last time when we did it on the same day, after the exam ended. Your exam is from 10 to 12, I think. 10 a.m. to 12 p.m. Maybe on that day, because the next days you have another exam. Next day you have G. The day after that you will have AECC maybe. So we don't want to keep things for the coming days. Viva we can take on that day only. Viva we can take that day only. This is the last page. For the time being, I would say that just begin your revision from the first day. First lectures are easily available. I shared all the PowerPoint presentations. They are in Moodle. And the link to my Google Drive is also shared with Neha and some of you. There you can find all the lectures. My lectures so far that I delivered. Most of them you will find there. Recorded classes. You can start the revision. Okay. try some numerical problems as well. I did few typical ones. We can try some more. So I think that's all. That's all for today. If you have any doubt regarding today's lecture, you may put forward, else you can move to the next class that is about to begin.
Thank you, sir.
Okay, thank you everyone. So let's
Thanks,
meet on Thursday. Okay, thank you.